Hello everyone, especially to our grade 7 learners. I hope that you're doing great today. I am Teacher Delia, your math teacher. Together, let's explore and appreciate the importance of learning mathematics. Now, prepare your self-learning module, paper and pen, as we are about to start our journey in learning mathematics. Today, we're going to learn on how to illustrate and calculate to measure a variability of n-group and group data. But before that, let's have first a short recap of your previous lesson.
Last time, you learned about the measures of central tendency, the mean, median, and mode. Now let's try to calculate the mean, median, and mode of set A and set B.
Now, what have you observed with the measure of central tendency of the two sets of data? Yes, you're right. Set A and set B have the same mean, median, and mode. How about the set of values? Of course, they differ in their set of values. That is why, in this case, it is important to measure the degree of spread of the values about the central tendency.
By observation, we can say that set A is less spread than set B. This measure of spread is also known as measures of variability. These refer to the measure of spread of values about a mean used by statisticians in evaluation, and the smaller dispersion often indicates more consistency and more reliability. There are four measures of variability: range, average deviation, variance, and standard deviation. Let's start with the measure of variability of n-group data. Range is the difference between the largest value and smallest value. To solve for the range for n-group data, for example, test scores of 10, 8, 9, 7, 5, and 3. Subtract the largest value, which is 10, and the smallest value, which is 3. Therefore, the range is 7. Let's have another example. The daily wages of factory workers. As you can see, the range of factory A is 575 minus 380, which is 195, while the range of factory B is 672 minus 400, and that is 272. Comparing the two wages, you will note that wages of workers of factory B have a higher range than the wages of workers of factory A. This tells us that the wages of workers of factory B are more scattered than the wages of workers of factory A. Now, let's proceed to the average deviation or mean deviation. It is the dispersion of a set of data about the mean or average of these data. The formula is this. AD refers to the average deviation, X the individual score, barred X is the mean, and N is the number of scores. Let's have the procedure in computing the average deviation. Letter A. Arrange the data into ascending or descending order. B. Tabulate the data. C. Find the mean for all the cases. D. Find the absolute difference between each score and the mean. E. Find the sum of the absolute difference. And F. Divide the sum by n. For example, find the average deviation of the following data. So you can see in the first column for our table, we arrange the data in ascending order. In the second column, we get the difference between the scores and the mean. And in the third column, we get the absolute difference. Now to solve for the average deviation, we divided the sum of the absolute difference by 9. So our average deviation is equal to 2.222. Now let's proceed to the third measure of variability, the variance. It is the square differences from the mean. Let's have here an example. We have there the score of 10 students in the spelling test written in the first column, and on the second column is the difference between each score and the mean, and on the third column is the square of the difference. Now by using the formula, we get the variance of 14.44. Now the last, standard deviation. It is the most used measure of variability. It is minimally influenced by extreme values, and it is the square root of the variance. In our previous example, our variance is equal to 14.44. So to solve for the standard deviation of it, we need to get the square root of the variance, or the square root of 14.44. Therefore, our ST, or standard deviation, is 3.8.
So let's proceed now to our next topic, which is the measures of variability of group data.
Measures of variability of group data. To solve for the range, subtract the upper class boundary of the highest class and the lower class boundary of the lowest class. Say for example, in this group data, the upper class boundary of the highest class is 49.5 and the lower class boundary of the lowest class is 14.5. Subtract the two, therefore the range is 35. To solve for the average deviation of group data, we need to use this formula, where AD is the average deviation, F is the frequency, X is the class mark or midpoint, board X is the mean, and N is the sample size. Say for example, here in our table, we already have the scores or the class, the frequency, and the midpoint. Now, we need to multiply the frequency and the midpoint, that is Fx. Now we can solve for the sum of Fx, that is 1575. Now we can solve for the mean, sum of Fx divided by total frequency. So that is 1575 divided by 50. So our mean is 31.5. Now that we already have the mean, we can now solve for the difference between the midpoint and the mean, or the absolute difference. After that, we can now solve for the product of the frequency and the absolute difference of the midpoint and the mean, and then get the sum of their product, that is 319. Now that we're done with our table, we can now solve for the average deviation, and that is the sum of the product of the frequency and the absolute difference divided by n, and that is 319 divided by 50. So our average deviation is equal to 6.38. Now let's have variance and standard deviation. Just like in group data, standard deviation is the square root of a variance. And we have here two formulas to choose from. We have the deviation method and the row score method. Row score method is preferable if the mean is a non-terminating decimal. In our given example, we need to get the square of the difference between the midpoint and the mean, and then multiply the product of the frequency and the square of the difference. Now let's get the sum of the product of the frequency and the square of the difference, and that is 2818. And now we can solve for the variance, and that is the sum of the product of the frequency and the square of the difference divided by n minus 1. So variance is equal to 2813 divided by 50 minus 1, and that is 57.41. Now that we have our variance, we can solve for our standard deviation, and that is the square root of our variance. So SD is equals to the square root of 57.41, and that is 7.58. In general, we have four types of measures of variability: the range, the mean or the average deviation, the variance, and the standard deviation. Remember that the dispersion of a distribution reveals how the observations are spread out or scattered. Take note that if the dispersion is small, it indicates high uniformity of the observations in the distribution. Absence of dispersion in the data indicates perfect uniformity.
I hope that you will apply what you've learned today to real life. This is Teacher Delia, your math teacher, saying, life without math is countless. So, start loving math and make every day of your life count.